So I just switched out some filament. I finished up with the OEM sort of natural ABS, and I'm switching over to the Octave fluorescent green. The color is actually a nice fluorescent green. The video is kind of a little bit muddy. A couple things to note: I'm using the Octave holder, tool holder, or spool holder. Basically has inserts for either the Octave OEM, the Afinia OEM, or the Octave ABS. It's a bit nicer than the one that comes with the regular up. This shelf tends to be a little shallow for the spool, so it kind of chunks when it rotates, and the filament sort of guide doesn't really have a hole or a spot for the sort of the PTF tubing, PTFE tubing here. Whereas you can see the tubing goes in nicely on the Octave style holder. So yeah, overall been really impressed. We'll see how this ABS goes. The OEM filament kind of melts a little bit hotter, around 260, where I think more than normal formulations ABS are lower, like 240-ish or so. So I'll probably keep the fan open when I'm printing with the sort of the budget or the Octave ABS. So I just loaded up the fluorescent ABS. I basically extruded it into the nozzle. One of the nice things with the Afinia software is you can basically, whenever you start a new spool, you basically select the material and what weight the material is. So it keeps track of how much is left as you print, which is nice. So you know it'll sort of warn you if you try and print something that's larger than the amount of plastic that you have left. Another thing to mention over here, use a little bit of a square of closed cell foam and thread the filament through it. That way, if there's any like dirt or little pieces that might end up clogging up the nozzle, they get scraped off that way. One thing I've noticed, just loading the Octave filament is definitely, it melts at a lower temp, so it's a little runnier coming out of the nozzle. I mean, that's something you're going to run into. Even with PLA is going to be even worse, which is kind of why they have this, I don't know what you call it. It's basically sort of active cooling. If you have this nozzle, if you have this flap down, basically it cools the filament less. You basically get a stronger bond. But if you've got tight details or whatnot, the filament might end up stretching as opposed to sticking in place. Also gives you some leeway with using lower melting point filament. So yeah, I'm going to do a print, see how it goes. It's a cool color, so it should be good. Flashing lights on the front of the unit, saying it's receiving the data. There's actually an SD card on the motherboard inside of here. So once it has sent the data, the printer basically starts printing. You can actually remove the USB cable. So you can basically do an unintended print after that point, which is pretty cool. So yeah, we'll just let it go here. The warming up for the nozzle is actually pretty quick, especially if you close this little damper here. The nozzle warms up a little bit quicker. And the bed, it's reasonable. Seems to be a good amount of power going into these units. I haven't had any issues with it taking a long time to warm up or anything like that. So yeah, we'll see. So we're ready to start printing here. Nozzle's up to temp. You can see there's a little bit of ABS hanging down. So it'll beep 4 times when it's ready to start printing. Gantry will come up. So I usually grab the excess as it gets close. I'm going to open up the damper. And so it's going to basically kind of get in place, and it sort of extrudes a little test. Basically to sort of get the nozzle primed. You might be familiar in Slicer and SkeenForge, it does a perimeter around the unit. It's kind of the same thing. I've had really good luck with the perf board. The plastic, the first layer really sticks down into the holes, which is nice. It gives you a lot of flexibility when it comes to leveling the bed. It doesn't have to be super precise because the plastic holds on so well. So yeah, I'm just going to let it run. It's doing supports right now. I've had really good luck with the rafting on this. So yeah, we'll just let it run and see how it goes. Let me zoom in here a little bit. You can kind of get an idea of basically doing some support here. And yeah, check back in a little bit. You can see here doing some of the thin threadings that it uses. Basically that's sort of like the removal layer on the rafting. So you can see sort of the thicker, stronger rafting underneath it, and then it does that sort of thin removal layers, and that's kind of how it peels off easily from the model that it's supporting. And I'm currently printing at 0.2 millimeters on normal, so that's almost the highest quality it'll do. You can do a fine mode, which basically adds an extra, 20% or so to the time. There's also a fast. I generally find myself printing mostly at the 0.2 normal. I've had really good luck with it so far. Quality's pretty good. I generally have enough free time that I don't necessarily need to print at the sort of thicker layer size or using the fast. So this has been printing for about 5 hours now. It's almost done. It's got a few more minutes left. So we kind of have a look at sort of the process. You can see a lot of the support material. You can see the support material for like the holes. There's like an indent there. There's a couple drill holes. So it'll be interesting to see how easy the support material is to remove compared to the OEM filament. So the print's done. Next thing is obviously get it off of the heated platform. It's a little difficult to get the clip off the back because of the arm there, so I generally just move it to the back so I can get it off. Grab the rear one. Move it to the front. So let's take a look. Looks pretty good. Definitely comparable to the OEM stuff. Let's see how the support structures pop off. Kind of just flex the board a little bit. It's definitely a lot harder to get the support material off on this. So let me come back when I have it off. So you can kind of see I got all the raft off so far. Definitely on there a lot harder than the OEM filament, but still comes off cleanly. You might need an X-Acto knife to get between the layers. But you can see it's still, there's still a good separation between the actual model and what the raft is, so I'm not super concerned. This ABS comes in a lot more different colors, and it's about half the price, so definitely if you don't need the added properties of the OEM filament, this might be your go-to stuff. So yeah, you can see the rest of it, the single thickness stuff comes up super easy still. I would just say it's more of an issue of maybe the raft. If the part has a large surface on the bottom, the raft can be kind of difficult to remove. Or just, not difficult, but just require a little more work. You can see these supports come out super easy, so I'm pretty satisfied, pretty happy with it. So I'll finish cleaning this up. So here we go, the part's finished. It's pretty straightforward. Even with this ABS, support structures came off really easy on the rest of the stuff. Just the bottom of it was a little sticky, but you can see support material that you have all these reliefs in here, holes pulled out nicely. I mean, that's one of the main selling points of this machine over others is the support material generation. Just the software is just way better than sort of the open source support material support right now. So one more thing I didn't touch on with the OEM versus the Octave filament is, I mean, since it has a lower melting temperature, people are saying that there's a better bond, interlayer bond, so you should get stronger prints over the OEM filament. So this one I actually busted up earlier just to test. This is with the just the natural OEM filament. It took a little bit of force. I mean, I think they say that ABS prints with filament are about 30% strength of solid ABS. It's going to have more weaknesses along layers. This one, the layers are printed like that, so it's sort of the natural weak point for it. So I'm going to try the same thing with the Octave print here. Let me just see what I can get. It's definitely definitely a stronger bond for sure. So I guess that's one more thing to think of too. So when trying to decide between the OEM or the Octave filament, OEM filament might be better for you know, finer stuff where you need to worry about the support material removal. So if it's, you know, if it's a small piece and it's more prone to breaking when you remove the support material, the OEM stuff might be better. But definitely, I think the strength addition of the Octave filament plus you know, the price and the different colors makes it you know, a really attractive option.